Welcome everyone. I'm really happy to see that even after the lunch, such many people on a software conference came here to listen about some hardware. Really glad to tell you something about it. My background for last 6 years was strictly related to hardware. Even I am not an electronic engineer myself, but I have this pleasure to lead a team of electronical engineers in building IoT stuff. And today I would like to tell you how does it look like from inside, from the kitchen, what we actually do, how do we do it, and then just after that, when we're on the same level of knowledge about IoT, we discuss some most strange, let's say, interesting use cases I faced during my career. So let's start. The main question is, what IoT guys actually do? Because even on the speakers' dinners 2 days ago, when I was talking to people, the most common question when you talk to another speaker for the first time is, what's your presentation about? And when I said, I'm doing IoT. IoT? And I saw in like 50% of people, I saw that they have it somewhere at the end of their mind, but they don't realize what's IoT about. It's Internet of Things, of course. Yeah? So connecting the world, let's say, it was a buzzword a few years ago. Now it made a lot of space for the AI. So if I ask my grandma about AI, perhaps she will tell me what it is. Yeah, but when I ask about IoT, it's not the case anymore. Anyhow, still IoT is happening. It's connecting the things somewhere, and today I will tell you how does it look like exactly. So let's start from the beginning. There are like 3 possibilities when you run the IoT business. The first one is the most common, I would say, is just rebranding and reselling. So you find suppliers in China, mostly. You find some niche, maybe smart home, maybe smart office, smart building, something. You order those components already with your branding, the huge container of that, and you are reselling in your country or somewhere around. The next case is you are becoming an integrator of third-party solutions. So you collect inquiries from the customers, from external world. They come to you with a problem, and you solve that problem using ready-to-use solutions, which is a bit more interesting because you really build something, you connect things together, you integrate with the software, with AI, etc., etc. But still, it's like reusing some things. And the last one is actually my field, which means designing new solutions from scratch. By designing, I mean if you want to have a smart home in your apartment, your home or something, you would like to have some sensors. What you do? You go to the shop and you buy them, right? Or you go to AliExpress, you just purchase them. They cost now almost nothing. So that's not my field. My field is if you can't buy anything on AliExpress and you need to design it. You have an idea for a new product. Let's say, I don't know, smart wallet. I need my wallet to be connected and have some sensor inside that if I leave it somewhere, at home or somewhere, and my kid is touching it, then I have immediate notification to my mobile phone that my kid is touching my wallet or something. So you can't really buy it on AliExpress, right? So you have to design it, you have to think about it, calculate, etc., and start. So what those IoT guys actually do? Let me show you step by step. First, there is a question from the customer. Let's say someone is calling me and asking, okay, my wallet, I want this intelligent wallet, okay? So we do, of course, the financial study, of course. If the customer is really able to finance that, and if that will be really a product which someone will buy and in this price, etc., etc. So what is the cost of the component? Is it optimal? Can you still have your margin, etc.? So it's a lot of business to be done. And when we finally agree on the agreements, we sign a contract, we start the project. And it starts with the design. So what you see now on the screen is Altium Designer. It's a professional software for designing electronic boards. Electronic boards, they are called PCBs. So if you have any kind of electronic equipment, let it be, I don't know, iPhone or any other kind of phone or a speaker or a camera, all of those devices, they have PCBs inside. The usually green electronic boards somewhere, and all of the components are soldered on them. So when you start the project, you know actually what it should do, what kind of inputs and outputs it must have. You need to design it. This is quite complex PCB, to be honest. It has 6 or 7 layers, so you don't even see all of the connections because they are going in the middle somewhere inside the board, right? And you need to plan everything. You have some central unit. In this case, you also have an edge AI computing model, which is connecting to inputs, outputs, to some memory, different stuff. You need to plan everything virtually to create the physical thing in the next step. So what happens next? We have this design ready. Of course, we verify it as you do a code review. So we do a code review between engineers as well. And we order that, in most cases, from China. We send the design, they send us back the PCB, because you need like a huge professional factory to create the board itself. This is the green one, the green thing. When it comes finally, like 5 or 10 pieces maybe, then we have to place all of the components on it. The machine you see here, the needle, is called a pick and place machine. You pick the component, place it on a proper place on the PCB, and then you bake it like you bake bread in an oven. That's an oven for baking PCBs. And it's quite specific case because some of the components needs higher temperature, some needs lower temperature, etc. And you need to do it like all together to have it finally ready. And you have it. You have all of the things on a PCB as the first step in your lab. And then you give it to your tester. You're saying, dear tester, this is our device. It should more or less do this and that. These are the ports, this inputs, output. Please test it and come back with the feedback. And what the tester does, it takes it and comes back in 50 minutes saying, this port is HDMI. This is like a regular HDMI port to connect the display, the beamer, LCD screen, or whatever. It doesn't work. So the tester can't do a thing because he cannot connect the display. He doesn't even know if the device is working or not. And this is what happens usually with the first version of the PCB, like with the first version of the code. Did you ever wrote a code which is working in the first round? Almost never, right? But it's much easier to correct the line in the code than correct the line in the HDMI port, HDMI. So I take it, I go to my engineers and I say, dear engineer, the HDMI doesn't work, please have a look. And somehow they are checking all of those lines, connections, they are checking if the current is actually going as it should. And after a few hours of investigation, the guy came back to me and said, we have this HDMI, it is connected, but somehow there are about 12, 13 pins which this port is using, and we made them as a mirror. They are in a wrong order. And this is something which you can't really fix. It's not easy. So because they go somewhere in the middle of the board and you can't just reconnect them. So what you do? Of the most common solution for that would be to correct your design, because you found perhaps this, the reason of the problem. You connect the design, you call your guys in China, you pay the money, then you wait 3 or 4 weeks and you have your PCB back. And that's the second iteration. But that's crazy. So you need to find the workaround. So you need to hire clever engineers who are able to make an adapter. So they connect 2 HDMI ports together. Those are like, 1 centimeter big, to be precise. And they reconnect the ports just manually. It took a few hours maybe. So finally they can use 2 HDMI cables instead of 1. So the ports are, it's like a bypass in a heart, what you do actually. And okay, then after that I give it back to my tester and I say, use this one for HDMI, then find another issues and come back to me with all of them, so we can have like just 1 more iteration of the PCB instead of 10. And we have it done in 1 month instead of 12 months. So yeah, this is how we learn. And finally, you have this nice looking PCB on a nice photo for, maybe not Instagram, but LinkedIn. Yeah, we have our product. Now the question is, can I sell this product? What do you think? Is it now, if I know it works, if I know I did all the quality tests, etc., all the ports work, the software on that is running, can I sell it? Of course I can't. And why is that? Because it is something like compliance. And if I create any physical device, which is doing some emission, then I need to do an emission test. It's called EMC testing. which is not done in our lab. You need to have like a sophisticated lab with, which has permission to do such kinds of tests. They have a chamber, they put the device inside the chamber, they power the, they provide the power supply, etc., and they test different frequencies, different level of emissions in different situations. And what we see here is the red line is the norm, is the maximum level allowed. The blue line is the emission which our device is actually creating. And the norm says, okay, if it goes above, then it's failed. It did not pass the test. To have this chart, we paid 2,000 euros to have this chart. And of course, we have no idea why there are these 2 or even 3 needles in this place going above the chart. No clue at all. Then we come back to our lab. Again, I said to this guy, you see the chart, now please have a look and fix that. So the next time we go to this lab, we pay again 2,000 euros for another test, and finally we can have the thing ready. There are still needles, but a bit lower. And they needed to change the hardware. They needed to create another iteration, first using like a prototyping way, just connecting different cables, etc. But finally we needed to order another, of course, from China to have it ready. And this emission test, what they are for, is because if my iPhone, let's say, would not pass EMC testing, then it might interact with your iPhones or any other devices or with the speakers, etc. This is just too much emission, which might provide some kind of, I don't know, conflicts, like etc., etc. So this is why we do such testing. And then, when I finally have it, can I sell the device? No, of course not. That would be too easy. The compliance usually might take about up to 6 months, to be honest, just to have them fixed. And after the compliance, I need to have like a CE mark. When you buy any kind of device, you have this CE. To have a CE, the requirement is to have the tests and like an official report confirming there is no higher emission than expected. And also, you need to have 2 documents: the user manual, official user manual, and technical documentation. When you have those 2 documents, you have the tests, CE marked, sellable. All right, so that's the process. More or less, that's the process. I did not even touch the software or a firmware on these devices, but you are software developers, you know how does it look like. Just imagine you don't write it on a computer or you write it on a computer, but you don't run it on your computer. You don't run it in the cloud, you run it on your device. So there are quite specific requirements of software, but it's not important at this point. So this is what we do. But who the hell is buying such stuff? Who is able to pay for a project which needs to be designed really from scratch, takes like 6, 12 months to have it physically ready for selling? And this is cost. This is cost of engineering, this is cost of components, cost of testing, of the compliance, everything. So there are not so many people who are eager to do that. That's why I showed at the beginning those 3 pillars of IoT. The most easy one is just to buy something from China and rebrand it. But if you have a brilliant idea for a product, you want to build it, then you come to us, we build it for you, you pay us money. That's the deal. And I have several use cases to show of the customers who were eager to pay for the solutions and from totally different industries, because my case is not industry specific. I did something for music industry, something for, I don't know, insects industry, which I will show you in a moment, or totally different stuff which I would never expect when I was starting this business 6 years ago. Warehousing. Imagine I have this inquiry, because everything starts from the inquiry. I receive a phone call from an unknown customer who told me, I need some electronics design, and I work for warehousing industry. Then just I open my imagination. I see warehouse. That's perfect. In warehousing, we have a lot of automatization to do. We have indoor tracking to find your goods in a warehouse, to find the way. You have like those automatic carts running somewhere. I know robotic arms, picking, placing, etc. Then he said, no, hold your horses. It's not about robotics, which is good because I don't do robotics, to be honest. It's not about AI. A bit worse, okay, but AI has a lot of projects, so maybe let's focus on IoT. But no, it's about rodents. So when I mention different kind of industries, including insects, I also include rodents. And the customer, what is he explaining to me? I provide a service to the warehouses that I'm protecting their goods inside the warehouse from the rodents, mouse, rats, whatever. Because if you're running a huge warehouse somewhere outside of the city, you have tens of those black, usually black or made from steel boxes, which, you know, the school on it saying don't touch, the poison is inside or something. So my customer is actually providing such service of taking care of the rodents around of the warehouse. If you have one warehouse, let's say you have 20 of such boxes, or 30. But if you have 5 warehouses, you multiply. If you have hundreds of warehouses in the whole country or outside of the country, you multiply, multiply, multiply. And imagine there is a mouse going in and just spending their next 2 weeks because someone actually needs to find out that there is a mouse. That's a real issue. And the customer provided us with 2 kinds of traps. The one on the bottom is a live trap, which means this way, or from the other side, little mouse came in and spends the rest of the life inside, especially if no one knows about it. It just dies of hunger, which is the opposite of, you know, the law, etc. So they needed to find a solution. Instead of going every day to every warehouse and checking if there is a mouse, they needed some kind of automatization. The one on the top is more brutal, because it's just killing the mouse. It's just, you know, locking itself when someone is there. The green box inside was used in both of them, and inside those small boxes, it's our design. It is, there are several requirements. Imagine you are outside of the city, there is no GSM connectivity, so you can't really talk to those devices. There is no Wi-Fi because it's a huge area. There's no Wi-Fi, so you need to find your own way of connectivity. And we use LoRa for that. It's a long-range distance connectivity where you can have multiple nodes. Like this is the node, I mean the device, like let's say client. And the server side is just one single gateway which can handle hundreds of those devices. And just this gateway, located somewhere in the middle of the warehouse, needs to be connected to the internet. But it must work on a battery, and for several years. And it needs to inform the customer that something is happening at least once a day. So that was the requirements. And of course, there must be some way to find out if there is someone really inside, is or was. In case of the mechanical one, it's easy because it's just a mechanical work. You can see the position of the thing. Yeah? But in this case, if it's a live trap, we use kind of a sensor which is being used in a toilet. Perhaps you know this, if you enter the toilet, the light magically turns on, right? But then you sit down, you start to scroll the Instagram, and someone decides for you to turn the lights off automatically after 60 seconds because that's the time good enough to finish your job in your toilet, right? Which is not the case. And then what do? Wave your hands, right? Just wave your hand, turn the lights on again. This kind of sensor, they are passive sensor, which means they are not consuming any energy. They are not draining the battery if there is no movement. So that was actually perfect thing for us. But they can, as they see your hands waving, they don't see you when you are not moving anymore. If the mouse is inside and it's moving constantly, the sensor will be triggered, battery drain, battery drain, battery drain. And after a few days, there is no battery. So there are quite sophisticated algorithms running on this device regarding the firmware development, written in C in this case, to make sure there is no battery drain and that there are no false positives. Because if this device is somewhere on the outside and there is a lot of sun, the whole box gets heat, accommodate heat. And there is a radiation. And because this sensor actually, it doesn't recognize the person, the presence, it recognizes the radiation of the body, etc. And the warmth. If there is a heat, or there is a car moving around, or there is a dog moving around or something, there are false positives. So we had really, the idea was simple, but implementation was crazy and took few months actually to be done. And the most important, no animals were harmed during this project. Why is it so? Because I took care myself personally of it, because the customer was calling me multiple times saying, just buy the mouse. I said, no, there will be no mouse in my lab. Test the solution yourself. Yeah? So the project took a bit longer than I expected, but still, we did not do anything to any kind of animal. Another industry, production. In this case, it's production of clothes. If you have such a huge plant producing clothes, you you are also afraid of something. The rodents is one thing, okay, they can destroy whatever you have inside, yeah? But the clothes producers, what are they really, really afraid of is this insect. It's a cloth mold. The small one, which is actually eating the textiles and making small holes inside. So you can't sell it, you can reuse the material, you can't really do anything if you have too many of them. And if you have just 2 in a plant, in a few weeks you can have hundreds or even thousands, right? So what they do, usually, they have this kind of lamp. Because the insect, as we know, they fly to the light, yeah? So behind this lamp, there is a big fly paper, like a sticky tape, so they get glue inside. And this is how they solve the problem. But that's not really the case. Because if you are running textiles manufacturer or something, you need to take care of different kind of insects than if you're running, let's say, apple production. And in some countries, like European countries, you need to report how many of those insects you have. So imagine a professional person who identifies and counts insects on such tape. 8 hours each day, like a regular job. I also was surprised because, as I told you, I'm not industry specific, but I would never suppose I would get such requests from the customers. And they asked me to prepare a solution to identify 23 different kinds of insects. Once a day. It's like a computer vision at the edge because it should not have any, a lot of power consumption, etc. So it will be like a wide-angle camera taking picture once a day of this whole tape and automatically identify and count the insects on that. This picture is AI generated. I use Midjourney because I did not have a proper one. And here the insects, they look like real insects, but imagine on a sticky tape. They don't look this way. So I don't know what will be the accuracy of the solution of recognizing 23 kinds of insects which are sticked like, It's crazy, but this is kind of a project we are facing, really. And now the customer is waiting for financing. So sometimes I feel maybe better he would not get that financing. Let's see. Smart home, next industry. Again, same as with the warehouse. When I hear about smart home, I think about Roomba, about smart TV, about leak sensor, door opening sensor, presence sensor, etc., etc. But there is something more. During last 2 years, I had, if I remember correctly, 3 calls from 3 different companies interested in something which you have around your house. Especially if you live outside of the city, on a village or a smaller city, etc. You have something which is called a septic tank. And septic tank is actually collecting all of the waste you put in your toilet or the liquids you put in your toilet, etc. Something which you don't put things in a toilet for fun. You put them because you want to forget about them as quick as possible, right? And it goes somewhere underground. And if you forget about them, then you might also forget about the level and space inside this tank. And what happens? What happens usually on Sunday morning when no one is able to collect that stuff for you? That is full. And you just, first you see this sound like, bul, 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 bul. And it goes up, 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 and it goes back to your home, to the place of the origin, let's say, which no one likes. That's not my customer. I just wanted to mention that I collected those pictures from perfect YouTube channel, which is explaining this situation, how the waste is going back to the. I recommend this one. Yeah, and the customers who were calling me, they are the producers of those things, of the septic tanks, and they are installing them, and they are facing this issue. They want to be the first on the market who is delivering the septic tank together with automatic measurement, which is, that doesn't need something like an Ethernet cable going from your home underground, etc. Because people don't have it usually. Then they don't think about it when they install stuff at the beginning. Because there are solutions. You can go to Castorama or Leroy Merlin or something. You can buy it for less than 1,000 PLN, but it requires cable and direct connection to your network in your home, which is quite difficult when you are not prepared for that. So they are requesting some kind of a sensor which you mount inside. And you forget about it. And just once a week, once a day, or even once, 2 or 3 days, it is checking the level of the waste inside and sending the information to the central system, who will be owned by the producer of those things, who is responsible for collecting that. So it's like a perfect service, customer happy, my customer happy, his customer happy, everything. Yeah? But the thing is, it's a really tough task. And for those 3 requests I got from Poland, no one was able to finance that. It's an unpleasant environment, that's quite obvious, right? No one would like to go there and do the quality assurance, let's say. And the funny thing is, it's kind of an unpredictable surface, because there might be liquid on top, it might be hard on top, you never know. And there's a different kind of sensor used for different purposes. The most easy one is called time of flight. Time of flight, because we know what's the speed of light, let's say, and we have such kind of sensor, we mount it on top. It sends the invisible light down there, and it reflects from whatever it's on the bottom and comes back. The sensor calculates the time, how long the light traveled, and based on that, he knows the distance. Easy, right? But if there is a water on top, it will not reflect from that water. It will reflect from something which is below, and you have totally different measurements, right? We can think about radars, but the radars are probably too expensive to use there. Yeah? We can think about some ultrasounds, etc. But what's happened if one day you really forget about it, even if you had the information? It will get flooded. Someone would go there and clean it? I don't think so. The enclosure of such thing must be really resistant to everything. To water, that's not the case. To acid, to any kind of chemistry you have at your home. And if you put it inside such a resistant block of something, you still need to connect it somehow. So you need connectivity from underground, from the enclosure working like a bunker. So taking into consideration all of those stuff, it's a kind of a huge R&D project, which we never know when it will be finished and done. Yeah? So without external financing, no one of the producer of a septic tank was able to finance that. Yeah? That's the case. And when I was preparing this slide, I asked Midjourney to prepare a proper image for me. Would you like to see that? I won't do that for you, because once you see that, I saw that once, and I would never forget about it. So just for your comfort and safety. Yeah? All right. When talking about smart home, I have one more case, but I received a phone call from the customer who I knew already. We did some projects together before, and that was a strange call. I was sitting in the office and just answered, and he said, Paweł, I hear sounds. I'm scared. I hear sounds at night. Can you help me somehow? It happens every night. Huh? So the relation was not so close. I was not able to ask him directly if he already visited a doctor. But I just looked around, how could I help him? And I was working at the time with the thermal cameras. So immediately I had this idea, okay, we are based in the same city. I have several thermal imaging cameras. I can send someone, they will install it around your house for a night. And if there is something, anything, we'll find out. You happy with that solution? Yeah, bring them on. Yeah? So that's what we did. And after like 12 hours observation of the home, looking for movements, etc., using a thermal imaging, we have, that's a haunted edition smart home, we have results. Yes. So after I gave him this movie, he told me like the potential of this whole IoT stuff is like unlimited. You can transform ghosts into Martin, like in less than 24 hours. Huh? And there was a continuation of this story, because he did some research, and he realized he had 3 of them living in the roof. And when you own a house, you have those Martins living in your roof. They had several entrances, like 3, 4, maybe 5. And if you find them, and if you block at least half of those entrances, they will perhaps move away without any conflict with you, and will just move to your neighbor, yeah? Which is the best option. The other solution is, of course, to call a professional company, but the professional company will just perhaps kill them. So we don't want to harm any animals, so the best option is your neighbor, right? And we also helped him with finding out where are the entrances, as finally he found them. And when he checked what's inside the roof, you know, there is a kind of a substrate in your roof which is making everything resistant to water and keeping warm, etc. Half of this roof, half of this substrate was already gone. So that was quite costly, but the martens are not there anymore, and they are happy living somewhere on the neighborhood. Retail, another kind of business. In the retail, there's plenty of things to do, especially connected with edge AI. So we have cameras, you know, we have everything which can, I know, monitor what kind of, there are ideas of customers, what kind of products can be in the most, you know, potential to be sold, depending on when they are placed on the shelves, etc. Counting people, heat maps, etc. But perhaps all of you remember this time when there was a limitation of a toilet paper per person, right? A few years ago. I believe no one knows why was it the toilet paper, actually, but two things were limited. The first one was the toilet paper, and the second was the number of people allowed to go into the shop, into the bus, into the tram, whatever, into the office, etc. And during COVID time, there was a lot of financing possibilities to fight COVID, to, you know, fight spreading of the virus, etc. So we started to do some investigation about how to solve this problem with the people, limit of the people in the house, how to count them automatically. If that's a trivial problem, there are trivial solutions, of course. So if you count people, you can go to AliExpress and of course you check, there are for less than €1 you can buy a clicker. Just, you need a person, like a security guard. This is how it happened actually in most of the shops in Poland, right? They are just clicking, one person, second person, and etc., etc. But how about the details? Like the entrance is really wide and the people are moving in parallel. You can't really count them. If there's a two-way movement, you need two clickers, a +1, -1, minus, bit, etc., etc. High crowd density, because in our shops we're fine, but in the, I know, Tokyo metro, it wasn't such easy. Yeah? Atmospheric conditions, because we quickly find out some kind of the sensor are not resistant to sunlight or water or whatever. Yeah? Height of the people. If this is a child, if this is an adult, should we count them? If this is a child, or maybe that's a dog. For the sensor, it's not so obvious, right? So recognizing them, we started to investigate available technologies to solve that issue. And we compared 4 of them. Time of flight, the one which I mentioned in case of a septic tank. Invisible light down there, reflection, coming back. So we know the distance from the object. Radars. You know about radars, especially to avoid them on the roads, right? So it works the same way. Thermocouples. It's if the time of flight is showing the distance between from the object to the sensor, the thermocouple is showing the temperature, working more or less the same way, just the input is different. Thermal camera is like a thermocouple, but very, very high resolution, so you can see the image like the martens. And we needed to collect some training data for edge AI model training. So we got in touch with one of the bus companies here in Poland. We made a prototypes just to collect data from all of those sensors, and the same in the offices. We have this, it's not really visible here, but there is some kind of a structure with the sensors on the top, just recording whatever they see. And let's say the time of flight. If you see the sensor, they are like these 2 boxes. Those are really, really small, let's say 2 areas, 2 zones, which returns independent data. The line in the middle is like the zone before the door and the zone after the door. So you know if the people is moving in or moving out. They are showing the distance from different sectors in this zone, more or less 230 centimeters above the floor. So if there is no one, you can see such output of the sensor. But if there is a person moving, you can see in this red box the distance from the person. Quite easy, right? So you just know, okay, someone tall like this is just moving from this zone to another zone plus 1 person. But when we did test with more people, this is how it looked like. And looking at that, no one you can hire AI or you can hire a student, and no one will know actually if there are 2, 3, 5, or 10 people moving at this time and in which direction. So the time of flight was not the best solution for us. And we also realized the time of flight is interacting, this direct sunlight is just breaking this light, moving down there and coming up. It's just showing totally strange results if there is a direct sunlight moving there. Thermocouples, they were doing good as long as there were no winter. And when the person is wearing a hat or a hoodie or something, it just can't see a thing. Radars, up to 2, maybe 3 people moving, was able to do so. But to be honest, there is one more issue with that. The signal processing of the radars would force me to hire 2 or 3 data scientists just for the signal processing. It was so complex. Thermal cameras did the best. They were showing more or less everything, but they are also the most expensive components out of these 4. So we started to buy some of them and compare like the higher resolution and the lower resolution. Both of them did well for counting people, but we faced one more issue. If you want to buy this one, the boson, you need to fill a lot of papers because there is a control of selling and buying them because they are used in military industry. And the higher resolution, like those one which I wrote on the top, are just not available for regular people. They are only available for military, for tracking bullets, etc. So yeah, that was kind of a limitation. And they're also quite expensive, so we used the one with the lower resolution, was good enough. Then there was a time of people detection model training. Like in regular AI, like the machine learning, we had a training set, we had a validation set, etc. We made quite a good accuracy. Because tracking people on a regular camera, like RGB, is you can just download those models and reuse them. Yeah? But in case of thermal cameras, there was nothing. We had to build the data set, we had to train the model ourselves using the YOLO framework. Perhaps you're familiar with that. But there are corner cases, like this one. This is entrance to the bus. Should I count this guy? He's giving a kiss to his girlfriend and leaving. Yeah? Enter the bus and left the bus. Is it +1 and -1? Should we wait for this passenger? Or he's just not moving? So in any kind of such projects, there is never 100% accuracy. It's just not possible. When I see this movie, I am happy because AI would never replace us. Someone needs to take a decision. If that's a person we count or just not the passenger. Eh? And that's the final result. 2 lines. Crossing those 2 lines in either direction, just counting people, even in case of fast-moving crowd, etc. So the thermal cameras did really, really well in case of counting. But then we moved to healthcare industry, and we had this brilliant idea. If we have the thermal cameras, we have knowledge, we have the stuff. Shall we also detect fever? It's quite obvious, right? It's a brilliant idea. Why not? Because the thermal cameras should actually detect the temperature. When we started, we quickly realized the limitations. The first one is, it is not measuring the body temperature, but the skin temperature, which is different even during one day. When you come here to the first today in the morning, your skin was really cold. It was like, I don't know, 30 degrees or something, yeah? Then after that, now it's perhaps 36, or I don't know, there is air conditioning. No one knows actually what's the skin temperature at the moment. So you need again an AI models to run it. And during pandemic, how the hell collect test data of people with fever? Who is going to give them to us? So when you work on such an R&D project, you are not allowed, of course, as a not medical person to go to the hospital and measure the people, etc. But you can sacrifice something always. And I, as a team lead, I decided the whole team will sacrifice 1 day of work. And instead of going to office, we went to sauna to heat our skin. And we did. We had really a nice time there, I must say. But next day, when we came back to the office and our analyst checked out the pictures, he said, unfortunately, we can't really use these pictures for training. And why is that? You see the hair and the eyebrow are the hottest points of the picture, which is not the regular case, because if you have fever, your skin is hot, but not your hair. And the hair on this picture is about 70 degrees Celsius. which is quite difficult. If you use such training data, then you know the rule, shit in, shit out. So the skin, which is the coolest part of this picture, was 45 degrees on this picture. Anyway, we can't reuse them. So keeping this in mind, one day I was leaving the office thinking, how could we collect this test data? How could we find anyone who is ill and can take the picture using thermal camera, which is quite expensive, and the problems. Yeah? And I opened the door of my apartment and I saw my wife just carrying this big bottle of medicine for kids. I said, what are you going to do with that? They called me again from the kindergarten. The guy is again sick, has fever. Yeah? Wait, did you give him that? No, I'm just going to stop. Then I called the guys from the office. Guys, could you please bring me thermal camera? And I have this one special family picture, unique. So that's how we collect test data for AI training in our lab. You see, the guy is shining. And what's interesting here, if you see the cheeks are not so hot. So we realize when we are looking for a fever, you actually need to look for the corner of the eye. That's the place when you can measure really if there is a fever or not. And definitely not the nose, not the ears, not the cheeks, but somewhere near the eyes. You're taking pictures of my family picture? That's okay, I just wanted to say it's RODO data protection, but it's not. Somehow, according to the law in European Union, thermal cameras are compliant with RODO. Lessons learned during 6 years in IoT, just to summarize what I taught today. Never trust a thermal camera, never, especially in case of fever detection, I must say, but for the counting it's quite good. There is always a room for automation. It doesn't really matter if it's a waste, septic tank, or insects, or whatever. So most of the cases we did, I would never realize I would be doing them in my life. Most probably ghost does not exist, which you can see on attached movie today. And the most important, buy houses only with a public sewage system. Avoid septic tanks. Thank you. That's it from today.